Okay, I think we are already plenty here. So I would like to welcome everyone, all the hosts, and HiPEAC, who is hosting this first webinar of our uCloud Edge IoT series of the RIAs showcase. We start our series with the showcase of the ICT 56 call project. So this is the next generation IoT projects, and we will have the presentations of ASSIST-IoT, INGENIOUS, TERMINET, INTELLIOT, and VEDLIOT. You should expect after this webinar to discover a bit more about the future of IoT from the insight of these projects, explore innovative solutions for open and decentralized architectures in IoT, and identify collaboration opportunities and network with these experts in the IoT landscape. So having this said, I would give the floor to Madeline as the representative from HiPEAC, who will be hosting this first webinar.
Hi, good morning, everybody. Thank you very much for joining us today. I'd just like to say thank you to Katarina and Albert from EU Cloud Edge IoT for the opportunity to host the webinar. And I think without further ado, we can go to the first speaker, who is Albert Soibers, who's representing EU Cloud Edge IoT. So Albert, the floor is yours.
Thank you, Madeline. I'm waiting for Katarina to share my slides, so...
Yeah, just a second. Okay, should be ready for you now.
Thank you. This just gives a focal point to the presentation. So yeah, from EU Cloud Edge IoT, we're hosting a series of these webinars. If you go to the next slide, please, Katarina. Today's slide, webinar is, okay, there's one slide missing, sorry for this. It is all about the next generation IoT insights, and I invite you to check on the EU Cloud Edge IoT website, because there is 6, 7 more of these webinars on cloud, MateOS, Swarm, cognitive IoT. So there's more to come on this. For today, we focus on next generation IoT, and I just have a few slides to take you into EU Cloud Edge IoT, and specifically for today, the IoT side. Wait a minute, Katarina. IoT is really capturing our daily life, where, say, 15 years ago, we would not maybe call it IoT, we'd call it connected sensors or devices. It's running from industry. So the Industry 4.0 initiative then was all about IoT and capturing data, because the value of the data we could capture through IoT or connected devices was gaining momentum today. And then we had it in retail, we had it in logistics. Domotica in our homes is already covered with it, but we see the extension in more changing business models in agriculture, retail. And I was leading for 15 years a smart city initiative. Cities are covered with sensor and technology, but we do not get the complete value of IoT yet. So the next generation IoT is really in demand, and see what it could bring. If you click on the next slide, you'll see that IoT is no longer the sensor. It's a network of sensors, but it's more complicated technology in the IoT side that draws the need for edge compute power, exchange compute power that may be available. But it also starts with the challenge on the next slide, is how to connect us as humans in this interaction of data, because it's also us that we're tracking with IoT, and it's us consuming the data and putting trust in the data that's shared. Simply models that we can have here is the public transportation lines that we have, but in an extended version. If we look at the autonomous car, it's going to be more disruptive. And it's what it needs is when and how we will, and this is the next icon, bring it to the cloud, and how we should make sure that we secure this, put it in human interaction, keep the human in the loop, as we could say. Indeed, Katrina, in the next slide. So this is for today. In the next slide, I will explain you here. how this links to the Cloud Edge IoT initiative. There's two CSAs cooperating today. It's Open Continuum that is driving the supply side interaction of the computing continuum landscape, and together with Unluxi, who's more focused on the demand side. So these are the objectives. It's similar. We promote an open industrial ecosystem for Europe, focus on open source and open standards. I think that's vital and very important. Last week we had this discussion on the open source days in Brussels. We have to work collectively to make this happen. But to make sure I understand what's already there, mapping the supply side, but also mapping the demand side to the supply side is an important aspect. And with these webinars, we hope to engage more of the industrial and research actors or communities to participate in this open source, open standards development for next generation Cloud Edge IoT technology. And this is where we have to coordinate this with all the relevant EU projects. So today, as I said, this is ICT 56, Next Generation IoT Insights projects that will take the floor. Next slide, please, Katarina. As joint CSAs, we have a number of task forces, and all the projects, if not yet participating in these joint task forces, I would invite you to look into these and see how you can participate and contribute to this joint undertaking, making sure that we have this European initiatives on open source, open standards, driving into the Cloud Edge IoT technologies. So we have a task force one that is focused on strategic liaisons. The 21st in Brussels, of February in Brussels, there is a big event where we connect projects that are invited to research, but also industry communities. We have the open source engagement. It's led by Eclipse. Make sure that one of the larger open source communities that we connect, not just to Eclipse, but to all the open source communities. Evident is leading the architecture, and this is a specific demand from the EC to come up with a unique taxonomy and a reference architecture for Cloud Edge IoT. It's under development, but in a month's time, we should be able to release the first draft and see how we can discuss this with the ongoing projects. Then we have the ecosystem engagement, and Luck, this is from BlueSpecs, is leading this. And the markets and sectors, it's research done by IDC to see how the developments are, what's happening in the markets, but also it will provide commercialization support to the projects. And then the communications task force, and Katrina here hosting this, supporting us for today, is one of the leading colleagues in this task force. Diving into, next slide, please, Katarina. And I will only dive a bit into this task force 6, because here is where we are today. Becoming part of this, make sure that we have at the moment 45 of the Research Innovation Acts in the community supporting the task forces. We have monthly meetings to make sure that we understand what events are happening and how you can participate in these events. What are the webinars? What are the physical events? What's happening? But there's also monthly news to be shared. And there's these workshops for the value chain adopters that we can make sure that we connect in the Cloud Edge IoT continuum, all these initiatives. So the contact points here, Katarina and Maria Giuffrida from Trust IT Services. So with this, I would finish my introduction to Cloud Edge IoT and the importance of the next generation IoT insights. And I will hand over to Alex to present on ASSIST-IoT as the first in line.
Okay. Hello, everyone. Let me start sharing the screen. Can you see it?
Yeah, sure.
Yeah, we can see it. Yeah.
Perfect. Hello, good morning.
Alex, just before you start, maybe just to inform the audience that if you have any questions, because between each presentation, we will have a few minutes for questions, so you can use the Q&A box or the chat, okay?
Perfect.
Thank you.
Thank you, Katarina. Well, good morning, everyone. My name is Alex Fornes, and I'm from the coordination team from ASSIST-IoT. I'm from the Polytechnic University of Valencia, and I will try to go a little bit fast through what have we developed in the project and what are the insights that we extracted. So these are the partners from the action. We have a set of research centers, SMEs, industry partners in order to not develop new innovation products and also to test them in realistic environments. So first and foremost, one of the main objectives of the action was to deliver a reference architecture for the next generation IoT, which has this basic conceptual view. This architecture was envisioned and developed with different views: functional, node, development, deployment, data, and it considers 4 different horizontal layers and 5 vertical ones. The horizontal layers are the ones related to resources, to network, to data, to applications and services, and then the verticals represent properties that are inherent to the systems or are cross-cutting to the rest of the horizontal planes. Moving to the next slide, once we define the reference architecture, we developed a reference implementation of this architecture and developing different enablers from the different for the different planes and verticals. The different planes and verticals can be mapping with the exercise that is now being carried out by the UCEI initiative. We have the device and explain which would map with the resource management. We have the network and control, which be related to the network and orchestration, data management. We have also self, which would be similar to the AI, security and trust. And so in the end, the effort that we have been doing here, it's also being reflected in the overall taxonomy that is being defined and used in the following actions. So 41 enablers have been implemented. Some of them are already public, with documentation also public. Some of them are still being moved to public repositories. And in the end, we have not made all of them from scratch. In some cases, yes. In others, we have used outcomes and evolved them from previous projects. And in others, we have used technologies that are open standards that are widely used by the community to avoid reinventing the wheel. So the assist orchestrator is one of the main outcomes of the action. It provides different features, orchestration features for the next generation IoT. It's compatible to manage services in IoT, edge, fog, and cloud environments. It's compatible with Kubernetes in the last versions, and also it manages virtual machine services over virtual machines. We have also implemented it in order to be able to manage these cases in IoT in which we don't have like a public IP address or a static IP address. In mobility environments in which we make change of the networks, we can also manage the services there. We have also implemented network security policies in order to prevent unwanted communications. This orchestrator is valid for many use cases from next generation IoT. We have tested in our pilot successfully. In any case, for more complex in which we have multi-domain multi-domain environments, these cases, there are some features that are missing, and the new actions are targeting them because they are more than IoT, more than next generation IoT. They are about this cloud edge continuum, but we are promoting this also in these actions. So how we have developed our enablers? We define a DevSecOps methodology. And we have the different, we have this DevSecOps methodology, which have different security mechanisms incorporated for publishing and developing the artifacts. We have our code, our packages, and our Docker images in public repositories. And we have developed a bunch of interfaces so the human can interact with these different enablers. We have manageability enablers, we have analytics enablers, we have cybersecurity tools, we have federated learning, our own dashboard in order to manage all the different cycle, and many other APIs, many other graphical user interfaces, which can be managed from a single point in order to manage the different artifacts that we have developed. The project has also implemented its own gateway, its own edge node, it's a multi-purpose gateway that has different connections widely used in the use cases like 5G, serial, Wi-Fi, Bluetooth, Ethernet, ultra wideband, also CAN. I think it also has CAN. It has also the baseline technologies that are needed for ASSIST-IoT to work, like a micro Kubernetes and different plugins that are needed for it to work. And the good thing about this gateway is that it is extensible. It has like 5 expansion boards in which if you want to increase the computing power, the memory, or other interfaces, it can be added to the system. So all the different enablers and the QEN have been tested in relevant environments. We have 4 different business scenarios, along with the open colors, have allowed us to test the different enablers that we have delivered and addressing many of their use cases successfully. Currently, you can see one of our pilot videos already in YouTube for pilot 2, the one of the smart safety of workers. The other ones are under preparation, and in 1 month they should be available publicly. So some captures from the different things that we have tested in the pilots. We have delivered applications for the port environment, so we can manage the different information in order to guide the different workers in the terminals, also the drivers where they have to position in order to gather the cargo, also some AI algorithms in order to detect the different materials, the different components that are in there in order to facilitate automatisms in the future. Also, we have tested remote control of the elements of the port environment of the cranes. Particularly in this case, we can see a driver of the crane working with it remotely. We have implemented some enablers in order to increase the reliability of the connection, so we can work with different wireless technologies, like if they were bonded like one single one with one of our enablers from the network. In other of the pilots, we work with the semantic enablers in order to have a common model for all the data that is used in the pilot. We have a semantic suite evolved from INTELLIOT in order to this, making it more accessible and easy to use. In order to interact with the users, we have integrated all the platform also with augmented reality classes, environments, in order to report alerts, in order to see the building. We have, for instance, an opaque color that allow us the possibility to mark in the different positions of the buildings if there is some kind of error in real time and notify it to the workers. We have also implemented some localization system in order to check if someone is going to a restricted or prohibited area. Also, we have used the WEN in this environment. In other of our pilots, we have been working with a car in which we have implemented some edge nodes and network capabilities in order to gather emissions data. And with this data, we have populated a database, and then we made a simulator in order to simulate the performance of a fleet of vehicles. Thanks to this, we can check if some sensors are failing, and we can go to the operator in order to point them where he has to fix it. We can send new calibration of the car ECU from a central position in case that we feel that it can be improved. In the end, we have tried to make that the data that we manage with the system is actually used by the users through tactile interfaces. So we included the human in the loop, and it's not just a system running without us affecting to it. So some lessons learned that we saw. The first of all is that the design principles that we used as pillars of the reference architecture are aligned with the recently started initiatives, meaning that they were correctly selected back in time. Also, the multi-cluster service mesh strategy was very powerful because we have different services of many technologies, different technologies, and these kind of strategies are very useful in order to facilitate the connection and the observability of the different services. We have also used, thanks to this technology, we can protect the connections with micro TLS and also increase it with network security policies. Particularly, we use Helm in order to package our outcomes. Other technologies could have been used. This is for the reference implementation. And it was quite useful in order to facilitate the tailoring of the configuration of the enablers for different environments. Now we're also working with operators in order to be able to configure more, to making updates of the enablers on live in a more powerful way, and we're exploring that. Now, in any case, there are some exceptions of the services of the enablers that we implemented. For instance, the cybersecurity tools, the agents that we implemented, we could deploy it in virtualized environments, but they are more powerful if they are deployed over the host. Some 5G functions like the UPF showed lower performance if we deploy them as containers. And also some devices like very tiny edge devices require dedicated configurations. They doesn't allow configuration. And the last remarks is, first of all, that we need to work more towards edge native. We have implemented cloud native trend in our project, but it's important that some of our enablers we saw that consume too much for the edge, and it's an effort that the community has to do to make solutions that are also working in very constrained devices. It's a field that we should evolve. Also, the cloud edge IoT ecosystem is very heterogeneous, and it's important that all of us talk in the same way. So it's a very good effort that they are doing in the USA CI for having a common taxonomy, glossaries, ontology of the continuum. This is very important. Also, this heterogeneity makes very difficult to have one solution that is working for the entire continuum for all the different features that it has. So we have to work on open platforms, marketplaces, reference implementation specific for the use cases. Of course, making it as open as possible, but try not to solve everything with one single solution. And what is very important, it's also to be aligned with industry, the commission, integrators, research, among all, because otherwise it's quite difficult to make that the innovation that we are producing in the projects arrive to the market. So I think that this is very, very key in order to be successful in the next actions of our research. So I try to go very fast. Too many things to tell in 10 minutes. I think that I took 2 more minutes. So thank you all.
Thanks, Alex.
You have any question?
Does anybody have any questions for ASSIST-IoT?
I have one question, Alex. This is Albert speaking. You mentioned a few networks you connect to. So you mentioned 5G, so cellular. But what about LoRa, Sigbox, Zigbee, the type of more commonly used IoT network still?
Yeah, for that, we used some gateways that we had from previous project from INTELLIOT. So we tried to reuse some of the software that we already have from previous project, not trying to make a solution over that. And we also tested or implemented in some of our solution Fletch, another open source solution, in order to gather this data and be able to ingest it to the rest of the system. So we didn't focus much on that part, because in the end we felt that there were already very good established solutions that we could use for this interoperability and ingesting data to the system. But yeah, we have it. It's just that we try to work above that, to what we do with the data, how we involve the users on it, put the human in the loop, and yeah.
Yep. Okay, thank you. Clear.
Thank you. Thank you, Albert.
Maybe a question from my side for your applications that you were showing. Did you use any, let's say, sort of root of trust, or let's say some trusted execution environments in the distributed use cases that you showed there? Was that something that you looked into, or was that out of scope?
No, it wasn't the scope of the project. In the end, we in the environments that we tested in the pilots, we have them considered like trusted. What we did is that some of the most critical actions that were important to know if someone has tampered, altered, or whatever part of the data, or have done something that they couldn't, we had some enablers based on DLT in order to log the most critical stuff. We also had a set of cybersecurity enablers that were monitoring different stuff. For instance, if someone changed the permissions of a specific user or a specific, but we didn't delve too much into that.
Okay, thanks.
Deliver some tools, but yeah.
So if there are no further questions, I think we can move on to the next presentation, which is Nuria Molnar, who will be presenting INGENIOUS.
Hello, can you see my screen? I think I was freeze for a moment.
Yeah, we can see
We can
it.
see it.
Okay, so Nuria Molner, I'm working on the Technical University of Valencia, like Alex, but in another department. I have been the deputy coordinator of the project, and it's worth to mention that this project finished almost 1 year ago. We closed the project in March last year, and we had a very successful final review last summer here in Valencia. And so what I will present today, it's outcomes, complete outcomes. And I will, for sake of time, just present some of the innovations we have demonstrated, but you can find everything in our channels, and you have the videos of the final demos in our YouTube channel. So the consortium was composed about 21 organizations of 8 different countries. And the main target of the project was to digitalize and automatize the whole supply chain, putting emphasis on next generation IoT solutions, of course, and 5G and edge and cloud computing, and some artificial intelligence tools. Since this is a big target, we divided the project into 6 use cases that cover the whole supply chain, right from the factory through transportation by land, then entrance in the port, within the port, and transportation by maritime transportation. And then the last use case would cover all the previous ones, ensuring that the exchange of data for the real-time monitoring of the assets is done in a secure way. We have done the demonstrations of the use cases in 4 real environments, as are the Port of Valencia, the Port of Livorno, a ship of Costco that we sent from the Port of Valencia to the Port of Piraeus in Greece, and a factory in the north of Spain of robots manufacturers. Then for each of these use cases, in the first use case, for example, the target was the enablement of 5G networks for industrial environments. And among all the demonstrated innovations, we have performed enhancements in the 5G core network with machine learning assisted end-to-end network slice support. Within the second use case, the target was the monitoring of cargo train carriages for defects and secure automating the reporting via IoT sensors. And among the demonstrated innovations, we have performed low-power vibroacoustic sensors that continuously monitor the train axles for defect using neuromorphic classification. In the port entrance use case, the target was to enhance the situational understanding of events in maritime ports and terminals. And among the innovations that we demonstrated was the development of a commercial AI system for predicting port container traffic rates and predict and detect congestion rapidly. It's worth to mention that this word commercial is real, because this was developed partially with from an SME of Finland, and they had this agreement with the Port of Valencia to share the data. So they developed this system and they managed to include it in their commercial portfolio. So right now it's a commercial product they have. Then the AGV use case, it happens within the port, and it targets to improve the driver safety by allowing the automated guided vehicles to operate in more scenarios, with humans assisting them via remote control in few difficult situations. And among the demonstrated innovations, we developed an immersive driving system with 5G networks with remote operator that controls the unknown situations that cannot be handled by an AGV on its own. Then the ship use case targeted the end-to-end tracking of assets in shipping containers. And among the demonstrated innovations, we sensorized a container for continuously monitoring the assets, not only within terrestrial trajects that are easier for connectivity, but also by sea. So we use satellite connectivity for that. And as I said before, we sent a ship from Valencia to Piraeus, and then we also sent this container by train from Valencia to Madrid and coming back. And in the last use case, the target was to provide interoperability among the separate IoT solutions and ensure the secure exchange of data along the whole process of the supply chain. And well, among the demonstrated innovations, we developed a data virtualization layer that ensures the interoperability of different machine-to-machine platforms, and also the read and exchange the data from external sources. One of the questions that we have been asked for this webinar was to think about how the project would contribute for the future of IoT. I would say all the use cases where the developments we have done in the use cases contributes to the future of IoT, but maybe one aspect that it's worth to consider, at least the idea of what we developed, is this virtualization layer, which, I mean, an abstraction layer is needed for ensuring the interoperability of machine-to-machine platforms that right now cannot communicate among each other, and interoperability is one of the keys for the future projects. And among other achievements, we have several success stories within the SMEs. For example, a couple of SMEs have created new products and services. Others have evolved the existing products they already had. And then we had also a success story of a big company acquiring one of the SMEs. So this company started as an SME in the project, but in the end, it was a big company, a big one. And then we managed also to have some collaborative agreements outside the project of several of the companies that right now they are continuing their collaboration outside the project. And well, this is among the SMEs we had, but also other collaborations that have started within INGENIOUS are continuing in different projects, both European and national. And yeah, that's among all the success stories we had. And then among the lessons learned, I would say that it was a big challenge to perform demonstrations in real environments because maritime ports and industrial areas are just complicated to access. So I would say that for recommendation is like it's necessary to prepare those demonstrations much in advance, prepare carefully the timings and the field requirements, and prepare early integrations and previous lab tests. And then another thing to consider that is very important is that not all the countries have similar laws. So what you may think that in your country is easy to get a license or something, maybe when you go to do test in another country, it's not that easy. So the help of a partner that is national and knows the domestic language is very helpful for applying to the licenses to the ministry and so on. And then the last lesson learned is not a lesson learned per se, it's more a reminder, but it never hurts. That is that working as a true team always pays off because there are always problems. We had, among others, a big one that is a partner withdrawal, and still we managed to deliver all the work that we promised and some more without delays. And that was absolutely thankful that everyone was willing to communicate and find solutions together. So that would close my presentation, and if anyone has questions, I would be happy to answer.
Thank you very much, Nuri, and thanks for taking the time to join us even a year after the project is finished. So if anyone has any questions, please feel free to ask. Okay, if something occurs to you during the course of the presentations, then we can always put that in the chat. That's no problem. So I think we can move on to the next presentation, which I believe is INTELLIOT, presented by Maren Lesher. Is that right? Maren, are you there?
Yes, I'm here. I hope you can also hear me.
Yep.
Perfect. Let me share a couple of slides, but also just confirm what Nuria said. I totally agree on the lessons learned. We are a project that I think we finished last week. We had a small extension, and there are a lot of learnings that you can also see in the past 3.5 years. And I think these are also learnings that future projects can apply. Let me quickly walk you through INTELLIOT. Similar to Nuria, I do not focus too much on the technology element. I'm the partner that's in charge of dissemination impact and business activities, and for like a future impact, I think especially also the exploitation and the dissemination activities were in our focus in the last part of the project. And we also had a lot of learnings attached to our open call, the collaboration across the partners, but also the business opportunities that came later on with small and mid-sized companies. Usually the projects run for 36 months. We extended till the 31st of January this year. So we are right in the middle of writing all the deliverables, finishing that up. We will have our review in March, and all the 14 partners out of the 10 countries that are currently involved are focusing at the moment on really reflecting what have been the learnings. So it's also a good timing for us to join this webinar because there have been some learnings that we identified in the past few weeks as well. We in total spent close to 900,000 euros in open calls, I think similar to the other projects. And this was also one of the learnings we had, the engagement, the collaboration with the broader audience. What do? We have the similar challenges like the other projects, the unreliable cloud connectivity, limited bandwidth, high round trip times, the costs of data transport and intake, privacy and trust, one of the topics that became extremely important for us, and also the lacking self-awareness of individual subsystems. We focused on 3 use cases: agriculture, healthcare, and manufacturing. When we proposed that, it was even before COVID, and one of the use cases is remote patient care, which became even more important right after we kicked off the project. These 3 use cases are overlapping also with some of the use cases from the other RIAs. And I think this was also one of the learnings that we had when we started exchanging ideas across the RIAs, when we looked into which SME are collaborating with us, who is focusing on which subtask in these main technical challenges. We also saw a lot of learnings and a lot of exchange was needed to also understand what is best practice from the others. The key element, and that was also mentioned in some of the first presentations from Next Generation IoT, is the human. The human in the loop was also one of the topics that we had to connect it, to have an interaction, to have a dialogue, but also use technology that allows to have this very rapid real-time exchange of data. Collaborative IoT, trustworthiness were 2 of the core elements that we had. So we had multiple challenges. Collaborative IoT, trustworthiness. We also added an infrastructure layer and the human in the loop. So we had these brackets that we work with and try to connect them in different ways in these 3 use cases that became our core use cases. We worked in 2 phases. In the first phase, we developed a core architectural framework together with also open call partners with small mid-sized companies that basically also filled some gaps in our partner network, provided applicability and maybe also ideas and products. And in the second phase, we optimized that framework, identified framework components and elements that are also able to be shared with others in an open source environment. And we also applied the framework in different domains to also test its applicability outside of the agriculture, manufacturing, and healthcare space that we predefined, in the beginning of the project. So this is the concept we have been working on, and just to give a bird's eye perspective, we have the collaborative IoT solutions, and we have the computation and communication infrastructure, and of course the goal was to connect it. You see that on the left side we have a multi-agent system that we have been working on together with the University of St. Gallen, a HiPEAC system, and on the right side you see tractors, you see robots, co-robots, and you also see wearable devices. These are the core elements that we applied in our healthcare use case to give the patients and the healthcare professionals the opportunity to track remotely wherever they are. And as I said, especially during COVID, there was something that was quite important because we've seen that a lot of patients really struggled with going to the doctors at that time not to get infected. So the multi-agent system was developed. The deployment was also done, and we developed an edge computing concept and worked on distributed AI and distributed ledger technologies. We established our own DLT infrastructure to test it out. Also, we're looking for open call participants, small mid-sized companies in the first phase of the development to support us to have more applicability. But we also learned that, especially when we looked for certain technologies in open calls, it was not necessarily all available, which also means that we operated in a research environment where not so many products were out in the market, which again, for research and innovation action, that should also be one of the key assumptions, that you have to invest in research and frameworks in the beginning, because all these activities are not in the market yet. And that was also something that we have seen when we had open calls and looked for very specific solutions. It was not so easy to find them and to identify them. The 5G and TSN infrastructure was provided by Eurocom and local partners. And I can also just confirm what Nuria said. We applied these concepts in multiple countries, multiple laws, multiple rules. And we also had to have a lot of checks locally to assess where certain technology is deployed in an easier way. And at the end, the human in the loop was supported by a small and mid-sized company called HoloLight that is part of our consortium. They are experts in AR, VR, and MR, and they provided also hard and software to have the human in the loop element covered. What we've seen is that when we worked on the architecture, we aimed for 35, 40 different components that we wanted to work on. Collaborative IoT enablers and trustworthy enablers were the ones where we identified the biggest lack. At the end, and you see it on the right side, we have 30 components that are available. Most of the components will be also in the next few days uploaded on the website to provide further applicability. We already have one-pager short descriptions of 19 of these components on our website. So people can also read it, can learn it, can also assess if these kind of components are applicable for them. I think that was also one of the topics that we have, this applicability, and also the question how these components can be applied together, how they can enrich existing technologies and concepts. And we also used open calls to do that. We did have, if you see it in the lower part, use case specific enablers. So of course, if you have a semi-autonomous vehicle like an off-road tractor, it's very different than having a wearable device, maybe also from a company like Garmin or other companies that are in the market or have been in the market for quite a while, and use APIs and SDKs to connect with them. We have reached the goals in terms of components that we wanted to test and make available, but we also saw that some of the components that we assessed might not be especially applicable for small and mid-sized companies, which we also learned in our open calls. Example, agriculture, I just want to quickly go through that so you see the complexity, not to block the time. But you see in this scenario, we had the goal to really involve the farmer we wanted to really apply the multi-agent system that we have, to cover all the opportunities. We wanted to have a semi-autonomous vehicle, a tractor that performs assigned activities, could be spraying, plowing, but we also really looked into farming fields and environments where there is a high risk for human health. Could be in one of our use cases is in Austria, because the fields are not flat. There are a lot of obstacles, but also in areas where weather conditions are hard for farmers and humans because it's super hot, it's super cold, or the terrain leads to tractors and off-road vehicles flipping and turning over. So we really looked into situations that are not the easiest, because some of the tractors you see around are already on the farm. One of our advisors are experts from John Deere, so we also closely work with industry partners together to identify what is the gap, what have they in their portfolio technology-wise already, and how can we enrich that. The human operator, the human in the loop, and especially the fact that we operated with AR, VR environments was something that was fairly new to them, and especially also our advisory board and John Deere experts, they really looked into that, and we are still in very close contact with them. We did a couple of demos in Steyr in Austria to showcase how far we came, provided videos, and we learned that it's very hard to get the tractor into demonstrations on trade shows, just because the vehicles are usually quite big. What's important to say here is that you see IKH here, I know how. This was one of the open call winners from the open call. So I think in months 18 within the project, we finished the first open call, and in the agriculture use case, as well in the healthcare use case, the open call winners played a very important role. This company provided a logbook that helped to optimize the processes. And in the healthcare use case, we even went a step further. The partner in the healthcare use case, Vidabo, became an official member of the consortium long term. So after the first open call for the other 24 months that the program ran, that the INTELLIOT project was executed, they become a full-fledged partner, not just for a pilot project. So we also identified partners that played a very essential role in executing. So in these areas, we worked a lot. We worked across countries, which is also the goal. So we integrated partners, and the contribution came from all different parts. The farmers we work with were from Finland, for instance. As I said, the AR VR environment was developed in Germany. The DLT solution comes from Denmark. We have the robot based in Austria. The logbook provided by this small mid-sized partner from Greece, and then the University of St. Gallen from Switzerland also provided the HiPEAC system, and the 5G infrastructure came from France. So I think it's a good example of how this cross European collaboration can also work. Security layers came from Cyprus. This is a little bit how it looks like at the moment, just as an example, but I'm also sharing some more examples. And I think due to time, I'm not going too deep into that. I just wanted to show you this. You see on the right side, the tractor is not as big as you might consider. So it's still fairly small, but there's also bigger ones. And as I said, I know how from Greece, as a small mid-sized company, played an important role, because they developed, as you see, the logbook that really helped us to visualize, but also to create an interface for the end customer, for the farmer, that also improved, of course, the business applicability of the concept and the use case that we have. To give you some examples on how we collaborated with small mid-sized companies, we had altogether 3 open calls. We had originally planned in 2. The first open call, as I said, in the first phase was supposed to support the 3 core domains. And we had rather large funds that we shared, because these partners, like I Know How, played a very essential role to really shape the use cases that we had and contribute to them. In the second open call, we extended the domain focused on energy, smart city, and construction, Also 3 domains that you will see in other RIAs covered as well. The focus for the second open call was the applicability. And then we initiated a third open call in a slightly different form for a few reasons. In the first 2 open call, we learned that there were a lot of very small and mid-sized companies, so-called micro SMEs with a very small number of employees, very, very young, that applied and wanted to contribute and wanted to collaborate and wanted to work on the next generation IoT solutions. But of course, for a 6 months pilot and a budget of 150,000, they usually were a little bit too small and didn't have the resources. So we decided to set up another open call specifically for micro SME in a field where we saw a lot of movement. And this area was the metaverse, industrial metaverse. So we saw a lot of demand coming in. And keep in mind, when you write an application for a proposal like INTELLIOT is like 4 years ago or 5 years ago even, in that time frame, a lot of things changed. So we learned that metaverse and iOS OS team attached to that are more important than ever. So we integrated that as a new topic, as a new domain area in our open calls, did a hackathon, invited especially mid-sized companies that were very, very, very small to join. And they also focused on topics that we did not cover in the other open calls, especially XR, VR solutions again, in visualization and a tactile environment, and also the dialogue between the technologies, autonomous vehicles, AGV in an industry environment, but especially also the multi-agent system that we tested has been applied, and we engaged with more companies. Altogether, 14 companies were engaged within INTELLIOT. These are the 6 winners from the second open call, from Portugal, Germany, Italy, Estonia, Greece, a wild mix, and we really, really enjoyed working with them. Some of them worked in predicting of parking and smart city environments like Dotsoft. We had an expert that worked on supporting hydraulic plants and offshore stations. So the energy area with AR VR solution. And this was one of the most surprising small and mid-sized companies that was engaged, and they used the components to the fullest. They used more components than we thought. They have a waste management system that they developed. It's a company from Estonia, very small. I think these 2 guys had incorporated the company a couple of weeks before they joined us, and they deployed the components to reduce the waste currently happening in the city environment. Just a few numbers to close off. So impact, as I said, for us, the small and mid-sized companies that we engage in the open calls usually continue using the components of INTELLIOT to enrich their products. They sell these services, so our components became also essential for the value creation of their products to increase their USP, and they also develop new licensing models and have new service models on top of what we provided. In general, we have across all areas, 25 exploitable results. We did a lot of workshops, also shared some knowledge. And we also see that collaborative IoT and especially infrastructure topics are highly sought after. The applicability for exploitation activities in these areas is super high. Collaborative IoT, I think, is one of the topics that we also see across the other areas. What's important is, from our point of view, that we also put a lot of effort into education and research projects. Again, to educate, we involved a lot of PhDs and students, shared the knowledge and trainings, and also looked into the commercialization. And the commercialization, similar to what Nuria said, is highly attached to also the business partners that we have to develop, value add services on top of the INTELLIOT framework. This is going to happen more and more in the future. As I said, we just finished also the technology development of the framework, are in the last stages of the project. And I think there's more to come. And if you do have any questions related to INTELLIOT, just feel free to ask.
Thank you very much, Maren. Does anyone have any questions?
Maybe a quick one from my side. You mentioned TSN, so time-sensitive networks or networking. What was the accuracy that you required for your different applications? So, like, was it in? So did you really, let's say, require the full 1588? Yeah, let's say accuracy for your application, or was it more relaxed, so to say?
Jens, I'm not a tech expert. I'm happy to connect you to our tech experts from Greece. So I would not be able to answer this very detailed technical question. Sorry.
Sorry. Okay.
But yeah, I noted down and I hand it over to these experts. I think one of the topics that we see is that the standardization and the exchange across the projects is quite important. So I think Nuria also said, do not reinvent the wheel at the end. But yeah, happy to share the question with the experts.
Okay, so do we have any other questions? Okay, so in that case, I think we can move on to the next presentation, which is TERMINET, and I think that's Anna, right?
Yes. Thank you, Madeline. Let me share my screen. Second. Can you see my screen?
Yeah, I can see it.
Thank you. So hello from my side as well. Thank you very much for the invitation for today's webinar. My name is Anna Triantafilou. I am a member of the coordination team from University of Western Macedonia regarding the TERMINET project. So as you see, TERMINET stands for Next Generation Smart Interconnected IoT. And we are currently at our final sprint towards the final review of our project, which will take place in March, just the same as INTELLIOT. So we are rushing through our final preparation. And as you can see, we're a large consortium. We are consisted of 26 partners coming from academia, from the industry. We have research centers and SMEs. So our final goal here in TERMINET was to provide a novel next generation reference architecture model, which is actually based on technologies such as software-defined networking, multi-access edge computing, and all of this combined together in order to be able to support different kind of cutting-edge use cases for the next generation Internet of Things. What these use cases are? These use cases had to do with applications in smart farming, in the smart healthcare domain. It had to do with smart sustainable and energy efficiency, something like regular to smart buildings. We had also use case dedicated to supply chain management and forecasting. Another one focused on group training surgery, which is involved in the smart healthcare domain as well. And last but not least, use case dedicated to ML-supported maintenance and fault prediction for equipment in critical infrastructures. This was our one of our industrial use cases. So in TERMINET, we actually wanted to create a platform, let's say, this reference model architecture that I'm saying, which was supported by an open programmable and agile network fabric. This is what the SDN technology was about in TERMINET, and which was also be supported by federated learning technology. The federated learning framework inside the TERMINET project was applied by two different approaches according to the needs of each of the use cases, because going through the project and the requirements of each use case, we identified separate needs for the use cases. So we created two different approaches for the federated learning. And the federated learning was used to enable the machine learning training in a privacy-preserving way. And we actually had a lot of lessons learned in this aspect. I'm going to going through them in a little bit. Another major pillar of TERMINET platform was the ability to support AR and VR equipment. And this equipment was especially utilized in the smart farming use case, where we had AR glasses for the farmers to be able to observe and to receive notifications according to what was monitored in their farms and at the fields. And it was also utilized in the sixth use case regarding the maintenance and fault prediction, where engineers were able to wear the glasses and also receive some kind of training or see what was wrong, let's say, with the equipment at that time, in order to be able to fix it in a much faster pace. And last but not least, everything was covered by a veil of security, let's say, a vertical framework that we had in the architecture, which enabled a trusted environment. It enabled ensured privacy during the whole data processing and exchange of information within the platform. And this framework of security was comprised of attestation services mostly, and also by blockchain technology. Here you can see an overview, let's say, of the TERMINET and where it actually fits in the IoT Edge Core cloud continuum. I will not go through technical details about the architecture. Our architecture model was actually comprised of 7 different layers. The first 3 layers had to do about the infrastructure part, as you can see the lower part of the figure here, where we had different kind of domains, the access, the edge domain, and the core domain. We had a layer focused on the physical devices, the physical objects, the IoT devices, where all the raw information came. Another layer, it was the middleware layer, which was corroborating closely with the intelligent layer, that had to do with all the machine learning stuff and the processing of information source to organize everything smoothly. And then we have the platform layer, where here sits the most of the TERMINET platform services, which receives all this kind of information, does the resource orchestration, stores everything in the right way, and then provides to the final stakeholders the final applications. We also have had open calls in TERMINET here, and we verified different aspects of the TERMINET platform in each one of these open calls. We had 4 open calls. 4 projects in one open call. And we managed to test different kind of federated learning approaches here in the open calls that we didn't have the chance to do it inside the project. So we tested the different application domains, different federated learning approaches. Okay, let me move on. An overview of our research and what we have done was that all the research done in federated learning produced some conclusions regarding how small compound data sets can achieve most measurable results by employing novel model optimization techniques in order to achieve better personalization. We also achieved the improved quality of the AI models, despite the fact that we had the let's say difficulty with different kind of application use cases, because we had to create different models for this each one of the use cases. So we experimented there a lot with this.
Μετά τις 12, voice 102,5 μετρημένα όλα όσα λέμε είναι εδώ, 102 και 5. Ο Ηρακλής Καραμονολάκης είναι στην κονσόλα, ο Γιάννης είναι μέσα.
Sorry, do we have someone whose microphone is on? Katerina and Eka, can you silence can you mute them?
Έχει διαδήλωση τώρα στις 12, έτσι δεν είναι?
Thank you.
Sorry about that.
Oh, it's okay. Okay, so through all the research in TERMINET, we managed to publish around 57 scientific papers. We managed to produce 8 data sets from federated learning experimentation. We also provided 28 exploitable items throughout the project that range from hardware equipment used inside the project to different kind of frameworks and platforms that were produced from the different use cases. And one of our major successes was that actually everything that was developed within the project was quite positively received by the use case stakeholders, especially in the smart farming use case and the smart healthcare use case. Actually, the dashboard utilized for the smart farming use case was quite promoted through the American Farm School that we cooperated with in use case 1, and also via a spin-off of the university, MetaMinds Innovations, which also managed to get the place of finalists in the accelerator program for a startup in the field of agriculture between China and countries of Central and Eastern Europe. So based on this dashboard. And all of the end users are actually quite involved and interested in continuing the work done within TERMINET. The doctors are in use case 2 are actually quite have quite well received the dashboard there, and we have created also videos on how these solutions created for the use cases are utilized. You can find them in our YouTube channel. Let me go on. So regarding the TERMINET's contribution for the future of IoT, I'm going to say that the project itself, the reference model architecture that we provided, is the major contribution here, because we created a model that can support data and connection with different edge core processing islands via programmable SDN fabric. We also managed to cover the heterogeneity of the IoT landscape via hardware abstraction and semantic enablement. We also managed to process across the edge to core to cloud continuum and to assure everything in a secure way by employing attestation techniques and blockchain. Everything discussed within the TERMINET project was also discussed with the sister projects that are here in the ICT 56 cluster through 2 policy workshops that we had. So we had some recommendations and discussions according to the standardization aspects of our projects and how everything came together in regards to the architectures as well for the next generation Internet of Things. A huge contribution from our side was the production of the federated learning datasets, as I said, that come through the different use cases of the project. So we have some datasets from smart farming, for smart healthcare. We have some security datasets also. Yes, and throughout the project, we also contributed in a number of open source projects and also created our own open source repositories from different aspects of the platform. We also discussed in releasing the interfaces of the core TERMINET platform and providing according documentation for further research and training. Everything will be available in the TERMINET website soon enough. And we had also some contributions, especially in the SDN technology and the federated learning open standards, as you can see here. And we have also created a patent regarding the attestation technique used within the TERMINET platform, as well as a reference architecture for the experimentation and research on digital twin technology. Yes, so what we this is an overview of what was done within the project. I didn't want to go to a lot of details regarding the technologies and the use cases due to the time, but I would like to also highlight that I agree with the aspects that Marin and Nuria said about the difficulties during the demonstrations and the validation of the actual platform. The different kind of connectivity issues in regards to the different locations and all this kind of technical difficulties, let's say. But we had a good collaboration within the consortium, and we managed to finalize the project smoothly. And until our final review in March, where we'll see the final results. So this is all from our side. And anything you can find in our website, and you can ask me any questions now, if any. Thank you.
Thank you very much, Anna. We've had a question in the Q&A, which is from Pooja Manani, and it's, could you briefly tell us about the data curation process in your project?
Data curation, you mean how we processed the data coming from the different application domains, you mean, towards the platform?
Yeah, then if Pooja, could you add a bit more detail to your question? Or in the meantime, Anna, maybe if you could.
Yes, of course. So what we did was we actually collected data from different IoT devices that either were sensors on the field in a smart farming use case, or medical IoT devices in a hospital. And then all of this information flow went through a streaming analytics component that we had. And then the streaming analytics component forwarded this information to the central TERMINET platform, where these components then were these data were processed by the intelligence layer that I mentioned, where all the machine learning processes took place, so as to produce some predictions about the raw data that came in, and then these predictions were highlighted in a specific dashboard for each use case. So this was how, in high level, the data processing took place.
Great. And how will it be available post-project as well, as the other part of the question?
A lot of these data sets are already in the Node and IEEE data port. You can also find the links in the TERMINET use case for each of the data sets that we have published. And we will also make public a documentation on how everything was processed within the TERMINET platform. So until the end of the month, it will be public on the website as well.
Mm-hmm. And thanks for unmuting me. And when you captured the data to IoT devices, so you followed GDPR principles, or how in federated learning, how did you anonymized, or what kind of algorithms, or not algorithms, but what kind of strategy or process was followed? I mean, that is because I'm from Project Paroma Med. And this project also is based on federated learning applicable to personalized healthcare. And there we are setting up a test bed. And we are going into stakeholder interactions and workshops. And so there is some learning that I could think that we could get from your project.
Thank you. Thank you for the question. So the good thing about our project was that we utilized federated learning. So it, by default, let's say, had privacy preserving manner on producing the predictions from the machine learning process, because we didn't move the data from the end user. We created just the models around the data. So the end users did not had to grant us permission to move their data from the edge. We just produced the models at the edge and then updated them through the cloud via the federated learning framework that we created. So the privacy was ensured during this process. Did you ask another question?
Thank you.
Maybe Puya, I can add, in our healthcare use case, we involved the ethics committee and had variables. So we also have a healthcare use case. I'm happy to connect you with the guys from the hospital and our partner Vidavo that had the variables, collected the data, and also had to follow all the GPR requirements. It looked like it was much easier in Greece than it could have been in other countries. Because there certain criteria or certain GDPR requirements were already set in the hospital environment. But our healthcare expert could also support and enrich what Anna just said.
Thank you so much. Yeah, this is something that is also important for our project. And since you already have some use cases on the topic, so I think it's a good way to understand, and also for future collaborations, maybe in webinars or publications, it would be nice. Thank you.
Yes, you're free to also send me an email, and I could also forward you to the healthcare use case leaders from our side for more information.
That would be great. Thanks.
Okay, so in the interests of time, unless there are any other questions, I think we should move to Jens Hagemeyer, who will be presenting VEDLIOT.
Okay, so can you hear me and see my screen?
Yes.
Okay, great. So yeah. I will just start right away. So maybe as an introduction, as let's say some of the other projects, we are also we also officially closed since 8 days now, and we will have our final review in March. What I'm showing here is what we call the VEDLIOT big picture with the hardware platform here at the bottom. Similar to, for example, TERMINET, we are having, or we are supporting a heterogeneous hardware platform composed of, let's say, on the one hand, different architectures like CPUs, GPUs, FPGAs, and on the other hand, the full scale from embedded, far edge, near edge towards the cloud. On top of this, we have, let's say, several microservers or accelerators, as we call them, which can be then composed to, let's say, the optimal architecture towards your given IoT application. And that was one focus of VEDLIOT, where we looked a lot into, on the one hand, third-party accelerators, and on the other hand, FPGA developments, where we built specific accelerators for our use cases within the project as well as within the open code. Then we have the middleware, because we have this focus on heterogeneous hardware. One important aspect of the project was how to then map the different hardware substrates towards the applications. For this, we had, let's say, tool chain, or a tool actually called Embeddle, same as the company, by the way, which is able to optimize and prune the networks depending on the hardware requirements. So on the final hardware that you are using to map your application. And we had also Renode and Canic, which are open source tools developed within the project, along with some other open source components that we have, able to do, on the one hand, emulation, and on the other hand, benchmarking and deployment in distributed IoT applications. This was covered by, on the one hand, the security and safety aspects, and on the other hand, the requirement engineering aspects for AIoT systems that we developed within VEDLIOT. From the application point of view, we had 3 core applications from the areas of smart home, industrial IoT, and automotive AI, as well as open calls, as many of the other projects also had within ICT 56. I will now briefly present the the key outcomes of the different layers that I showed here. Here you see the VEDLIOT hardware platform. with these two dimensions, let's say. So you have on the one hand the, let's say, far edge towards the cloud, and in the other dimension then really the CPU, GPU, FPGA, dedicated ASIC or machine learning SoCs in the different form factors. This, and as you can see, we are covering quite a lot of technologies here. We are building the whole thing based on top of open computer or module form factors. We are active in the respective standardization committees from, for example, PICMIC or SMARC. It means that we are, let's say, also driving and contributing to the respective standards in that field. Then on the next slide, you can see what, let's say, the VEDLIOT idea of co-design or full co-design is. So really optimizing the different deep learning accelerators and the models, let's say, from the tooling perspective at the same time, to then really reach the optimal performance and accuracy required by the application. So you can, for example, then prune your network, I don't know, add some compression towards your hardware accelerator, or for example, prune or, let's say, reduce the data accuracy, so the data types, for example, from float to int or things like that. And what you see here on the right then is for, let's say, different accelerators, for example, the Xilinx DPU here, or let's say our FIBA accelerator, that we used different implementations of the same network compared with respect to accuracy drop and speed up, so to say, so that you can, let's say, trade accuracy versus speed depending on the actual application requirements. Because as you all know, let's say, you need a certain accuracy, but depending on the application, higher accuracy does not necessarily mean that you're really achieving something towards your application. So it can, in the end, make no difference whether you have a higher accuracy and then you can either, let's say, achieve higher speed up or save energy by simply saving computations. On the security side of things, VEDLIOT made or has made a number of, let's say, contributions towards open source. We have been heavily using WebAssembly and integrated trusted execution environments for the main architectures, which are x86, so something like SGX, ARM, so something like TrustZone, or RISC-V into WebAssembly. So by, let's say, using standard interfaces on the VEDLIOT website, you can see our different open source components. So if you're interested in running trusted execution environments, so TEEs, into WebAssembly, this is definitely something that can be interesting for you. We also did some advances on attestation by adding a distributed so Byzantine fault-tolerant attestation service in the project towards the application, which is also an open source component. This is what we call the compositional architecture framework for AIoT systems developed within VEDLIOT. This is really a methodology, and there's also a tool behind this to create your IoT application from scratch during the full design process. So really from the analytical level down to the runtime level, covering multiple aspects like the AI, the hardware, the communication, quality concerns, even ethical constraints or something like this. So by applying this model, you can ensure that you are meeting, let's say, requirements like for example the AI Act, that you are meeting some regulatory constraints from, for example, the automotive sector or something like this. This is something which we felt is quite a nice outcome from the project, because it enables you to design your system or your application in a systematic way. Towards the application that I was just talking about is, so I would now go across the 4 key use cases within VEDLIOT. As said, we had much more from or 10 additional more from the open calls. The automotive AI use case in VEDLIOT was dealing with pedestrian detection and avoidance scenario. The goal was to detect these pedestrians here on the road in, let's say, urban as well as, let's say, more rural situation on the countryside, for example. And the challenge here was really to the distribution of the work. So it was not an application or a scenario running purely on the car, but let's say also then on the edge and even on the cloud. So within this, we really made experiments here on let's say in the field, so on an airfield as well as in a real environment. We distributed that this distribution of work across the full computing continuum works, and we even gained 2x efficiency improvement within the. Another thing that we have in the project is let's say drive condition classification use case. So it's a predictive maintenance scenario here. Key idea is that you have these big electric motors and you are retrofit, let's say in a retrofit manner, attach a small monitoring device to this motor, so to say. So the challenge here is that those are really low power, because even though the motor has a very big, let's say, cable connection, this device needs to be battery operated because it's attached in a retrofit manner and should also operate when the motor is not powered. And by simply monitoring things like the vibrations, the magnetic fields, the temperature, and so on, it should be able to basically predict when this motor need maintenance, when it's going to fail, something like this. So this should then really operate for years on a battery while still maintaining, let's say, some good predictability of the motor condition. And we demonstrated this with more than 2 years battery lifetime, which is more than 7x efficiency improvement compared to the previous solution that we had there. We were also dealing in the same domain, so in the industrial IoT domain, with an arc detection use case. It was about predicting, or let's say detecting arcs in DC distribution cabinets. So for AC, this is more or less solved. For DC, this is something which is still pending. So the challenge here is really accuracy, because if you are detecting an arc and you are wrongly detecting this, so this is a false positives, then you are shutting down your production plant for no reason, which is an obvious problem. And even if there is an arc and you are not detecting it, so basically a false negative, that's also a big problem, because then you might cause a fire and you're not able to detect this. So accuracy is really key, and we demonstrated more than 99% accuracy here with a 20x efficiency improvement. So in terms of energy efficiency again, compared to let's say the previous prototype. And finally, we have the smart mirror, which is a use case basically doing local face recognition, object detection, gesture detection, as well as speech recognition. Challenge here is data privacy, because if you have such a thing in the bathroom, you don't want to do the computation in the cloud. So we are doing everything locally, which leads us to an energy efficiency challenge again, because you still want to be able to pay your electricity bill. We've demonstrated here the local processing with a 9x efficiency improvement. So to summarize this, the key results from VEDLIOT are the scalable, heterogeneous, and cognitive IoT hardware platform, covering on the one hand, let's say, modular, scalable microservers from, let's say, CPUs, GPUs, FPGAs. I showed all of this, and also spanning from embedded, far edge, near edge towards the cloud. We had demonstrated or developed this co-design approach, where we are really optimizing the model, optimizing the hardware or the accelerators at the same time. And I did not show this in the interest of time, but we also have done an extensive benchmarking campaign in the project, benchmarking more than 40 different microservices, and the results are available in several publications and also on our website. And we have developed certain or a number of open source components for trusted execution environments within WebAssembly, and also distributed remote attestation. And we demonstrated the efficiency improvements in order of magnitude for a wide range of use cases. I showed the central VEDLIOT use cases. We have more in the open calls. When you're asking what are the key lessons that VEDLIOT showed, from our point of view, that let's say that this heterogeneity and the reconfigurability or adaptability, if you want to call it like this, for next generation IoT platforms is really key if you're looking at it from a sustainability point of view. Because if you want to, let's say, make IoT systems, let's say, capable of doing AI within, let's say, larger deployments, then this needs to be efficient, because otherwise it will simply not be sustainable. And you need to be able to, let's say, keep the platform for, let's say, at least 5 to 10 years. Otherwise, you will also run into sustainability problems if you need to, for example, exchange these IoT platforms as you exchange your mobile phones. We need to have the tool coverage for then also leveraging these heterogeneous hardware. So I guess also TERMINET was talking about hardware abstraction layers. This is something which is key, but it should not, let's say, hide away the different possibilities of the, for example, particular FPGA or GPU platform. Security and robustness are mission critical for a large number of IoT applications, for example, from the industrial or automotive domain. And within VEDLIOT, we have developed components to enable this. And we also think that this systematic requirements engineering, so the architecture framework for designing AIoT systems, is something which is of great use for the community. So that's all from my side. Thanks a lot. If there are any questions, let me know.
Thanks very much, Jens. Does anybody have any questions for VEDLIOT? It's interesting that you mentioned the sustainability aspect, because obviously producing the platforms is also very CO2 intensive. So it's good to see.
That's why we need to use them for a long time. Otherwise,
Exactly.
we will not be able to deal with that. So we need to deploy hardware. We need to deploy systems which are able to adapt to, let's say, future demands, which means that reconfigurability is key. And they need to be able to be used, let's say, not just 2, but maybe 20 years.
Okay, so I think as we're a little bit over time, unless there are any questions now, then we can probably close. If anybody does have any further questions, please do let us know. We can contact the panelists and get answers for you afterwards. Albert, did you want to make any final comments, or Katarina?
Well, thank you, Madeline. Yeah, I will. I think we listened to 5 very inspirational sessions. Some of the projects are ended, but leave legacy for us to work on, and that it will be made available, I'm sure. So I would say thank you to Alex, Nuria, Mara, Anna, and Jens for the presentations, varying from the use cases. It's interesting how IoT impacts and how we see the hardware we need. Jens touched on the sustainability part, but bringing the human in the loop, bringing us as the human, acting or reacting, responding to the data that's shared, and support the technology that will respond to the data that's been gathered. As you said, Madeleine, if there's any further questions or discussion we need, it's an interesting topic. So please refer to the organizers and make sure that we bring you in contact with the presenters. My last call out here is that I said in the beginning, it's the first in a line of webinars, and I'll urge you to check out EU Cloud Edge IoT website. Make sure that we follow this, and you can follow the sequence of webinars. The next will be on software technologies, but Cloud Edge IoT is indeed cloud. Now we had IoT, and the cognitive cloud major operating systems are the ones to be followed soon. The new projects on Swarm, and we'll follow up in a bit later state, I guess. So thank you now for joining us today, and looking forward to meet you again in the next webinar that we will be hosting.